Can you just move one slide back, please? Good afternoon, everyone, and welcome to this session on optimizing total cost of ownership for AWS. Let me make it a little bit. Okay. So today, so my name is Rohit Rahi. I work on the AWS product marketing team, and I'm really fortunate to have with me Valentino Volenghi from Adroll, did I pronounce that correctly? Who is going to talk about how they are running their operations on AWS at a really large scale while being really cost effective. It's a really fantastic customer example. So what we are going to do today is we are going to look at three different things. We are going to look first at the total cost of ownership. And basically what it means is when you are running your operations on AWS, you always ask this question, what will it take to run on AWS? What cost will I incur? So basically the first part is dedicated to answering that question. What is the cost to run on AWS when you compare with on-prem? Then Valentino is going to come on stage and talk about Adroll operations, how they are running at scale while being really cost effective. And then finally, we are going to look at cost optimization on AWS, which is basically how can you reduce your spend on AWS. So you are already running on AWS, how can you reduce your spend? So let's look at the cost aspect of AWS. So cost is often the conversation starter when it comes to cloud. And across the board, there are multiple ways you can save money with AWS. The first benefit which customers get with AWS is they can really trade in the capital expense with variable expense, operational expense, because they don't have to lay out all the capital for building out data centers, buying the expensive hardware, spending all that money upfront. The second benefit they get in the cloud is the variable expense in the cloud is much lower than what companies can do on their own. And this happens because AWS fundamentally runs at a much higher scale, and we pass the scale advantage back to customers in form of lower pricing. We just announced our 42nd price drop today. And so, we'll talk a little bit about the pricing philosophy there. And then across the board, there are multiple ways, pricing models, billing models to serve your workloads, whether you're running steady state workloads or variable state workloads. So the pricing model which customers are most familiar with is the on-demand model, where you show up, pay by the hour, use the resources, we charge you, you stop using those resources, and you stop paying for those resources. So that's the on-demand model. For customers who are running steady state workload, there is another model called reserved instances. And using reserved instances, you pay a low upfront fee, and then you choose to reserve for 1 year or 3 years, and in return, you get roughly half the cost of on-demand hourly rates. And we'll look into how reserved instances work. And then finally, we have this spot market, spot instances, where at any given time, we take all the excess capacity existing in our data centers, and we make that available in a spot market. And you bid on those instances. If your bid is higher than the market clearing price, at any time, you choose to run those instances. You get to run those instances. If it's not, you don't run those instances. So there's a special class of workloads which can really leverage that. We'll look into what that looks like. And then finally, AWS also has tiered pricing. So for things like bandwidth and storage, the more you use, the less you pay on a per unit basis. There are reserved instances discounts, and then there is custom pricing for customers who are planning to do complete data center migrations. So we negotiate these custom pricing. So across the board, there are multiple ways you can save money with AWS. And when we do this, the logical question we always get from customers is, sure, you can save money in the cloud, but what about my on-prem environment? So if you just look at this chart, you have physical environment, which can be a complete physical data center, or it can be a complete virtual data center, and most of the data centers would be somewhere in between, not completely virtualized or completely physical. And then there is AWS in the cloud. And so you looked at the cost structure. The economics are fundamentally very different when you're coming from on-prem. And why is that? Go back and ask yourselves, why does that happen? And there are three things which you should always consider. The first thing is cloud runs at a much higher scale. Our VP, James Hamilton, did a presentation at last reInvent. I highly encourage you to go and view that video. It's available on YouTube. And his talk was basically focused on why scale matters and how cloud is really different, right? And it's a lot of content here I just taken from his presentation. So much fundamentally higher scale. When you're running at a higher scale, you have things like supply chain optimization. Your procurement time is lower. You don't have hardware sitting on the shelf. Then secondly, if you have to just pick one lever to reduce your cost, it is utilization. If you think about why virtualization became so popular, it is, single factor was it drove the utilization on the physical machines, right, physical servers. So what happens in an on-premise environment is you really, get to somewhere from, 20% to 50% utilization. When you go into the cloud, because you have so many diverse workloads, non-correlated workloads, they tend to average each other out. So your aggregate utilization is much higher. And then finally, we have, custom hardware. So software is where all the magic happens, but you can optimize your hardware. So they consume less power, less space, they're more efficient, and so they're less expensive. So you have custom servers, you have custom networks designs, you have custom storage designs. So if you look at these three factors, basically because of these factors, your economics in the cloud are very much different than economics on an on-premise environment. And again, I don't want to spend a lot of time here. Andy touched on this in today's keynote. Basically, there is a virtuous cycle going on here. So as more customers use AWS, they drive the usage of the platform, we have to buy more infrastructure. So we get economies of scale. The previous slide was talking about that. So it lowers our infrastructure cost, and we pass the cost savings back to customers in form of lower pricing. I mean, today we just announced the 40-second price drop. Just a show of hand, how many people really like the price drop announcement and they're really happy about that? Come on, it should be everyone. So we pass these savings back to customers as our own infrastructure cost comes down. And then third-party analysts have independently verified some of our cost savings. So in 2012 and 2013, AWS commissioned IDC to take a look at customers who are running on AWS. And IDC came back and said that when you are running on AWS, your 5-year total cost of ownership is 72% cheaper than running on premises. And you also get some benefits like increased IT productivity. And the thing which customers sometimes tend to overlook is the value which AWS provides. So it's not just the cost, it's the two facets of the same coin. So it's the value you also get with AWS. So look at this. They interviewed customers who were running anywhere from 7 months to 5 years, more than 5 years on the platform. And if you're running only for 3 years, every dollar invested gave you close to $3.50 in benefits. And what are these benefits? These benefits are increased user productivity, increased end user productivity, lower downtime, things like those benefits. But then as you use the platform longer, let's say from 3 years to 5 years, your benefit tend to increase. Your benefits tend to accelerate over time. So this is a very subtle point which you should remember. So when you're using for a longer time, you gain more benefits. Why does that happen? Fundamentally, two reasons. First, as you are on the platform, you ride that learning curve, so you're more optimized. And secondly, you are putting more applications into the cloud, and you are leveraging, getting more benefits, if you're running a substantial portion of your infrastructure in the cloud. So having looked at AWS cost savings mechanisms, looked at on-prem, looked at some third-party independent verification, let's go into the meat of the first part of the topic, which is of the talk, which is comparing total cost of ownership with on-prem versus cloud. And I say that on one side there is total cost of ownership, the other side is partial cost of ownership. And we'll look at what partial cost of ownership looks like. Why is this so difficult to do? There are 3 or 4 things which you should always consider when you're doing TCO. The first thing is in any traditional enterprise or even a small or medium-sized business, the cost visibility is just missing. It's lacking. For example, facilities guys always pay for the power and cooling bill. IT doesn't pay power and cooling. So IT doesn't know what power and cooling bill looks like, right? There is no visibility there. The second thing is the way you handle cost is very different. So there are capital costs, your data center, your infrastructure, your hardware, and then there are operational costs, which is your variable cost. So the way you treat them is very different from each other, right? And so you have depreciation periods, amortization periods, 5 years, 15 years. So all those, different periods are there. Then, granularity is missing. How many people know, your servers, how much power they are consuming, what is your network look like, how much power the network consumes, your storage spindles. It's super difficult to get that granularity. And finally, you have your data center administrators, your virtualization administrators, server admins, storage admins. How are they spending their time is not easy to put in a model. Are they spending half their time, looking into the cost, into the infrastructure? Is it like full time? And so it's, so those are some of the challenges when you are looking at comparing TCO on-prem and between on-prem and the cloud. So what is the model we use typically? So the model we use looks something like this. So at a fundamental high level, there are 4 different areas which you should always consider, and this is total cost of ownership versus partial cost of ownership. So the first area is you should always look at the server cost. This is by far the most, the biggest part of your cost. So server cost means your hardware cost, your software cost, and I'll touch on those yellow cells, what those means. Then you look at your storage cost, again software, hardware, same thing with network. And then for each of these items, you also have overhead cost. So what is the overhead cost? Overhead is basically things like your space, power, cooling. How much are you spending on those things? And then finally, for each of these areas, you have labor cost. So you have storage admins, you have network admins, you have virtualization admins. How are they spending their time? So all that has to be factored in. One thing which I would say here is this is for new applications. This is not really migration. So a lot of customers ask us, how do you treat migration? So if you are migrating from your existing data centers, then you need to add something on migration cost. How much will it take to migrate? Can you tolerate that downtime? What about the software licenses you have already purchased, the hardware you already purchased? So again, there are nuances there which you need to consider when you are doing a migration. This is for net new applications. So now if you just step back, right, you look at that picture which I just showed you, and you step back and you compare with cloud. It's again not an apples to apples comparison, and that is again a challenge when you are doing a TCO. So if you just compare with cloud, you have all these things which I have listed out. The thing which customers always look at is the hardware price. So they would look at a server and they would say, this is my server cost, and this is what I'm paying, my OEM, X hundreds of thousands or whatever that amount is, and they miss everything else which is listed there, with those red sign. Things like your space, your power, your cooling, your rental if you're renting out space, and more importantly, and Valentino will actually touch on this in his presentation, would be things like the software part of your infrastructure. So for example, auto scaling. If you want to implement something like auto scaling, what would it take for you to do that? If you don't do it, are you really getting the cost benefits of an elastic infrastructure? What about your personnel cost, your security folks in the data center, your admins, all those costs? So, if there is one key takeaway from this session, it is basically this. When you are looking at your cost, just don't look at your hardware cost, your server cost. Look across the board and see, where are the areas where costs are incurred. And so, I just wanted to have a couple of slides on a typical engagement we would do with customers, and these are actual customer data points where and I just wanted to show you how we typically do a TCO analysis. So the first thing we do is let's see if there is a pointer here. There is no pointer in here. So the thing which we do is we look at your on-prem environment. So in this case, if you look at the table on the extreme left-hand side, you see different virtual machine configurations, having cores, RAM, how much are they being used over a period of time, Then when you are coming from an on-prem environment, you can choose to optimize your instances. Are you really looking for virtual cores? Are you really looking for RAM? Are you looking for disk I/O? Are you looking for network I/O? And depending on that, you might get different instances on AWS. And we'll talk about what this means, picking the right instance types. And this picture here is basically showing you different price points. So the size of the bubbles are actually the prices, the on-demand prices, and the different instance families we have. So on-demand or compute or general purpose instances. Not all instances are shown here, but what you can see here very clearly is at a particular combination, on a particular combination of CPUs and RAM, you can pick multiple instances. At not every point, but there are data points where you can pick these instances. So again, you have to decide what is more important for you. Is it CPU? Is it RAM? Is it I/O, storage, or network, or whatnot, right? So, and again, we'll touch on this. And this is the output from a typical TCO engagement we would do with a customer. So, the important things to notice here, and I'm sorry, I don't have a pointer to point here, but look at some of these, donut charts. And the reason we do that, sort of surface that up, is to show you that wherever data points are missing, make use of some averages. One thing with a TCO exercise is don't go nuts on, going into the details. Like my storage is consuming 5 watts of power, and how much will it look like for next 3 years? How much my cooling is going to cost? Don't go over every single minute detail. Leverage some of the industry averages, the benchmarks. So for example, if you look at the leftmost donut chart, and sort of hard to read from here, you can see what is your breakdown of overhead versus hardware cost versus software cost, and then make use of some rules of thumbs. Like overhead is always 50% of my total cost, or overhead is 100% of my total cost. If you do that, you will have a much better result than going too deep into each of these areas and figuring out every single detail. Just not worth your time. And just a couple of slides before I get Valentino to talk about his use case. Dow Jones International, global provider of news and business information, owns brands like Wall Street Journal. They did this exercise, and they went over each of their applications one by one, and they picked every application, and they did a TCO analysis, and they said, does it make sense to run it on the cloud, or does it make sense to run it on-prem? And as a result, they are moving away from 40 data centers currently they own or rent to 6 data centers, only 6, and they are migrating all these applications. But the crux of their migration was this TCO analysis. They made a business case whether they should move to AWS or not, and in the end result, they're planning to save $100 million over next 3 years while with doing this exercise. So just to recap the first part of this talk, what you should consider and what you should how you should think about TCO, and the things which you should not forget. So things which you should always remember to add in your model would be things like your power, your cooling, your space, your data center administration, and some of the things which listed there, your software cost, your storage cost, if you have redundant storage, if you have redundant network, what is the cost of each of them, right? So just don't look at the server hardware cost. If you go through this checklist and make sure you are considering each of these items, you will have a much better TCO model. And then also think benefits. You are reducing that procurement time. What does that lead you to do? You get some cost benefit out of that. You reduce the number of lost customers because you cannot scale up quickly. What does that look like? So things like that, right? So just consider some of these points here. You'll have a better TCO model. So with that, let me bring up Valentino, who will talk about how he's running a massive scale operation while really being cost effective. So it's really fantastic example. Yeah, I think you're on. Thank you. Yep. Please.
On. Can I have the remote? How do you switch? Just press here. Yeah. Okay. So, hi everyone. How many of you here know what Adroll is or does? Just a few. Okay, that's good because I have an hour-long presentation about that. Okay, so Adroll is the biggest retargeting platform on the web today. Retargeting is a specific form of advertising, specifically called behavioral advertising also in some circles. And what that means is that essentially Adroll helps you collect, analyze, and act on the data that is sitting on your website. In specific, the way that Adro works for you today is that it allows you to place a small JavaScript tag on your site, and when people browse your website, they generate log lines that Adro ends up collecting for you. The immediate step after that is that we see the same cookies and the same users trafficking all around the web across all the different traffic exchanges that exist today. And every one of the impressions that happen on any site, it could be the New York Times, could be Facebook, could be a surfing blog, or whatever site you guys decide that you want to visit more often than the others. Whenever the page is rendering, all of the different banners that are present on the website are shipped out and sent to an exchange, and they are auctioned off in a real-time auction that happens in about 100 milliseconds. In this 100 milliseconds, our systems need to decide whether we are interested or not in this impression, how much we want to pay, and what is the effective prediction ratio of this impression clicking or ending up in a conversion afterwards. In the cases where we do decide that this impression is actually worth our time and our effort, we actually serve an ad and end up winning that bid potentially, and the ad shows up on the surfing website. In order to do this, though, with 100 millisecond latency tolerances, you actually have to be spread out all around the world. 100 milliseconds are not enough for the speed of light to move a byte from Singapore to the east coast of the US or the west coast of the US. So you actually need to be on-prem where the traffic is generated. In the case of traffic exchanges for the web, this actually happens all over the world. Somehow it happens to be very well aligned with where Amazon has data centers, so Oregon, New York, Singapore, Dublin, and Tokyo, and so on. So in order to do this effectively, all of our data needs to be replicated everywhere around the world. It's not enough to just have a big single data place where all of my team is allocated and I can efficiently run this single space in the world. I actually need to have a global organization. And at some point in time, we have had to be a startup before we started to do all of this. And a startup that is capable of running a global business is a fairly unique thing in general. Not only this, but we have more than 10,000 customers in more than 100 countries around the world. Our data volume is going up at speeds that we were not thinking were even possible when we started all of this. We started in, the company started in 2009 with this specific product, and in 2011 we were around 50 gigabytes a day. Over time we doubled and doubled and doubled. Today we manage about 50 terabytes of data every single day in March 2014. But even a few months ago it was just half of that. And so it's kind of complicated to even get reservations for S3, for example, because our costs on S3, our growing keeps going up and up and up, and it's hard to find a specific growth trajectory. So what do we do effectively throughout Amazon today? We store about 1.5 petabytes of compressed data inside S3. That's uncompressed is going to be about 10, 11 petabytes. We need to be available worldwide. All of our data needs to be replicated everywhere in the world where we needed to access it at sub-millisecond latency times. And we handle the traffic of the web for what regards advertising is about 50 billion impressions every day. All of these need to be responded to within 100 milliseconds. Industry standard says that as soon as you start to have a 2% timeout on these 50 billion requests, so 2% of these 50 billion starts to be above 100 milliseconds, you start to be throttled. We need to be throttled means that essentially they stop sending you as much traffic as they can, and you only see a fraction of it. At the same time, you need to be as close as possible to 100% uptime. Adro announced last year, early last year, that we have reached a $100 million run rate. If in 1 year we make $100 million and our uptime is 99% instead of 100%, that means we have lost $1 million. It's very easy to make a direct correlation between our uptime and how expensive it is for us to not be up all the time. And how are we doing this? We're doing this with 35 engineers. But that's just me inflating the number, because until 3 months ago we were 15. In 3 months we actually more than doubled the size of our team, and we have another 15 engineers coming up on board. So if you put that together with the 1.5 petabytes and the 35 engineers, you see that the ratio of terabytes per engineer is extremely high. Facebook is rumored to have a data center of about 500 petabytes somewhere in the world, and they have 6,000 engineers, I think. Their ratio is actually way more favorable than Adderall's. And it's a lot easier for them to hire people now that they are super rich with their IPO and whatnot. So how do we use, I am going to present a couple of use cases that we have within the infrastructure that could go a lot deeper in the ways and nuances in which we use Amazon. But there's a few data points that are really staggering. One of them is our usage of Amazon S3. As I said, we have 1.5 petabytes of data compressed inside Amazon S3, and we grow that by 5 to 10 terabytes every single day. We actually add about 200,000 files every day to Amazon S3. In all of this, it's not even enough. If you add 200,000 files every day, it means you do 200,000 requests every single day, but we also read all of this stuff because we need to process all of this data, obtain proper insights for our customers to act on. And that means that we run 5 billion requests every single month on our Amazon S3 buckets. And we also transfer every month 500 terabytes of data. That means that 30% of our data, or our full total data stored in S3, is in flight every single month. And we keep processing and processing and processing that data to give the best performance to advertising campaigns for our customers. And how do we do this? How many engineers? We have none. No engineers in the Adro engineering team are spending time on managing 1.5 petabytes of data. We just have it there. We don't really know that it's really running. At 5 billion impressions per month, we are actually one of the Adro S3 buckets are actually some of the most visited properties on the web. And the funny thing is that it's our infrastructure that is generating 5 billion requests per month. And the even more complicated piece of this is that usually infrastructure is a lot more sensitive to variations, to issues within latency times and whatnot. If our Hadoop jobs are running and they need a file, they're not going to wait for 3 seconds before going away to a different place. If a file doesn't get there within 300 milliseconds, they're probably going to fail up. If the job is running with 1,000 machines and it fails too often, then I have wasted 1,000 machines worth of cost. If I'm running it in my own data center, I'm going to run into very expensive energy costs, and at some point it's not going to make much sense anymore. But the real thing is we don't really have engineers working on any of this. In any case, we went through potential alternatives. It happens that in March 19th, not too long ago, Backblaze, and I love this company. I've read all of their blog posts on their website since when they did the version 1 of the storage pod. And every one of their posts is really, really insightful in all the technology and all the care that they put into building their stuff. But the last post was really puzzling to me. They ended up, the article was about building a 100 petabyte data storage data center. And they talk about the latest version of their storage pod, the version 4. The version that they talk about in the article stores about 180 terabytes and costs about $10,000 and only has one PSU in that box. So if that PSU goes out, the entire box goes out. So in order to mitigate that, you actually need to usually triple the storage, and you need to store your data points in different machines to mitigate the single PSU. So you go 3 times that cost in order to mitigate local concurrency. Then Amazon S3 offers zone availability. So if one zone were to go down, your data is still available because Amazon S3 replicates in multiple locations. And so you multiply that item by 3. And then you want to have room to grow. You don't want to run 180 terabytes to 100% usage. And so you want to run around 50%. So you multiply that by 2. At that point, you also add some spare capacity, something that you keep in cold storage so that if any machine fails, you can replace it very quickly. These storage pods take 2 days to be filled in with data. It's part of the article. And if you don't want to have to wait for a while in order to receive a machine, assemble it, and then put it in the cluster, and then have all of the disks get filled and warmed up by the entire software that you've built, then you need to have some machines around there so that you can quickly act on something that is going to fail. If you multiply all of this, you end up with $250,000 for the first 180 terabytes. Now, clearly, when you're scaling this to, instead of 180 terabytes to the petabytes or the tens of petabytes or hundreds of petabytes, your ratios are going to change, and it's going to make a lot more sense when you reach those levels. The point, though, is a startup or anybody that is going to need to start and set up their proper storage pod, their sticker price for the first 180 terabytes is $250,000. It's not cheap. And this is not even all of it. You have to develop the software that is managing these machines, that knows how to properly allocate the data parts, the data blocks into the different machines so that the failure of one doesn't mean that that data point is not accessible anymore. You need to write the software that manages 5 billion requests every month. That's not trivial by itself, because it also needs to be fault tolerant and be capable of reallocating traffic and resharding as you're adding new nodes or as you're removing nodes or you're acting on top of all of these things. And there are all the electricity costs, there are all of the, in general, bandwidth costs for bringing data inside and outside of this. There are people that are operating this. Interesting tidbit, James Hamilton, again, as Rohit said, had a great talk about the nature of the cloud. Data center is fairly interesting. The more, of all the machines that you could put in a data center, the heaviest ones are the ones that do storage for you. So Amazon has actually developed their own technology, apparently, for an extremely dense storage layer. So that they can put as much capacity as they can in a very small space. The problem, though, is that the floor of the data center actually needs to be reinforced. So when you start to get to a space where you're accumulating a lot of storage capacity, your data centers start to be a little bit special. When you start to scale at a certain size, nothing that was simple when you were small remains simple. If you had a failure every 10,000 times that you did something, when you do something a billion times, you have a failure every very short time. And our bill in AWS for storing 1.5 petabytes is the equivalent of having 6 engineers more in our team. 6 engineers more that are going to do all of that. Operate a worldwide storage system, run it at scale, never have it fail, always be available everywhere in the world where we need it, and develop the software that manages all of that. 6 people. That's just, with the competition that is out there today, especially in the Bay Area for engineering talent, we do not have 6 engineers to spare, 6 extremely smart engineers to spare on something this complicated and this scalable. We're not a storage company. This is not going to add value to Adro. The fact that we can store 1.5 petabytes of data means nothing to our customers. We are expected to store 1.5 petabytes of data. It's our job. But it's not what we sell. And so we just happen to have a similar amount of data to what other storage companies do. It's just that we cannot possibly spend time in doing that. So in reality, you can all scratch that. The Storage Pod 4, when it came out March 19th, came out with a cost per gigabyte of 5 cents per gigabyte. And today, Amazon just removed that, and it became 3 cents per gigabyte. So we're not even talking about a comparison on a per gigabyte cost at this point. It's just cheaper. So I wasted all the time writing these slides before this presentation came out, and now.
Yeah, I got an email from him saying, hold on, I have to, send you my updated slides. It's like price is completely changed. So.
Yeah. I don't even know how you guys make money anymore, so I'm going to give you $1.
Oh, thank you very much.
So you make your quota.
Thank you very much. This is the lucky dollar I'll keep. Thank you.
Okay. So the other use case that we have is our RTB infrastructure. These are the machines that bid 50 billion times every day. They are more than about 500 machines. They're spread in 4 regions. As I said, we need to get up to about 100% uptime, and we have reached 100% uptime since when we launched. They are humming along at about 100 millisecond latency overall. And since this year, and last year was the same, we are at about 0.15% timeouts year to date, and they're probably caused by our own ignorance of running systems at this scale. At the same time, we're also leveraging a lot of other infrastructure within Amazon. One of the main pieces is DynamoDB. We're running more than 500,000 requests per second on DynamoDB throughout the day. And even in that, there's so many problems that you run into when you run stuff like this at scale that you actually lose touch of how simple the problem was when you started with it. I'm just setting a key, and retrieving a value at the end of the day. So what's happening here? And the reality is that latencies and single milliseconds make a big difference. And one thing is getting to 50, 100 milliseconds of latencies, or getting to running a few million requests every day. Another thing is going to 50 billion. Every single micro instruction that you're running in your software counts. Every single network hop that you touch counts. And not all of this, but in order to be moving fast and deploying our software quickly, we need to have certain flexibility in deploying our software. We developed everything in order to do all of this, and we are capable of shutting everything down and bring everything back up in about an hour. There is no real skill needed in anyone that is inside the team in order to deploy all of this software. And how many people did we use to do all of this? 2 engineers. 2 engineers started to implement our bidders, and they scaled them up. At some point, we ended up having more traffic, and so the auto-scaling groups started growing and growing and growing, and we kept deploying, and nothing seemed to fail. We were capable of continuous scaling and focus purely on writing the software, writing the logic that was bidding, never worrying about how many machines we needed, never worrying about, I have already purchased these machines with 50 terabytes of disk, now you need to use 50 terabytes of disks. Or I only have machines with 2 CPUs and so on. We actually have more people installing and managing the software and the computers that we have in the office. And they always seem to be failing. The internet in our office fails far more often than the internet inside AWS. We also looked at alternatives, of course. You can run your numbers your own. Some business make more sense than others, of course. In our case, we have 4 data centers. We actually run in 6 inside Amazon, but let's say you only have 4 data centers for running your RTB infrastructure. You're probably going to have a need of 2 people on call in every one of these data centers. It's cutting it short. When one is on vacation, the other one can't go on vacation. If one is in the restroom, the other one can't go in the restroom. You have, as I said, I have about 500 instances running at any point in time. Let's assume that you don't need, I put there 1,000, but let's assume that your machines are a lot faster than Amazon machines because you're explicitly providing them with whatever you want. The matter of fact, though, is that you're going to have to over-provision them. What we're getting in Amazon is the ability to provision all of the different versions of our clusters in parallel. And the only thing that we are left with is just deciding which version is going to survive afterwards. And all of this, if you're going to do it in your own data center to replicate this, you have to implement your own auto-scaling and your own common API. You can use OpenStack, perhaps. You need people to manage all of that, and you need to have people that are deploying patches to that software and that are keeping it up to date. You need to also provision 10, 20% extra capacity. You need to do this because machines fail and the supply chain might not be up to date. The main reason, actually, that we moved inside AWS in 2008 was because overnight we had 3 disk failures on the same RAID 5 cluster. We were 1 disk away from losing everything and having to go back to backups. But we didn't have any drives there because 3 or 4 drives failed also the week before. And the only way that we could get them was to order them, and there was a 3-day wait. And we spent 3 days praying to whatever type of gods or omni-powerful people were out there to not have another drive fail, because we didn't have another way to replenish those machines. So you always want to have that extra capacity. And what happens if a big customer signs up for Adro? What happens if Google signs up for advertising through Adro? Who knows? Are we going to say no to Google? That's not something that you want to do in your startup. My CFO and my CEO are going to come to me and slap me in the face and say, what are you talking about here? It's Google. And what happens if we improve our algorithms? Engineering team is always incentivized to improve the algorithms and make sure that we can run in less machines and less time. And they want to experiment. So one day our algorithms are not at the best of their shape and we need 1,000 machines. Tomorrow we improve everything we can only do with 50. And what do we do with the other 950 machines? At that point, they're just wasting energy and they're just around the data center and not doing anything for us. So it ties us down to the actual hardware. And what happens after we've properly released all of these machines and new CPU comes out and does some crazy new feature that we really would like to use on the hardware side, but we already have bought these and they are amortizing over years, and who knows how long it's going to take us before we can upgrade. And it's actually not super simple. Parts are going to get outdated, and all of this is going to be very, very complicated. So what we are essentially doing is we're trading money for time. Essentially, we are willing to pay a little bit more money in the short term to have a slightly bigger data center or run some inefficiencies because we need to be capable of executing very quickly in other priorities that might not be the cost right now. But at some point in time, we'll have the ability to go back, look at the problems that we've had in our algorithms, optimize our algorithms, or change the decisions that we made, and throw away all the extra instances, all the extra hardware that we needed back then. And so we end up with what? We end up with the ability to use a resource that is far more scarce to a startup or to a company than money is. You cannot save time. You can only save money and use money when you need it. At some point, though, if you don't have time to implement something and your competitors are doing something that is very, very interesting to you, you need to address the competition. You cannot address your cost issue right now. But if you are dealing with your own data center, now what? Now you're stuck with some machines that you don't need anymore in a few seconds. But overall, what does this mean inside numbers? So all of this is nice and talk, but in order to implement your RTB infrastructure, as we said, for regions, so 2 people on call, that's 8 people on call over all the world. You need a product manager to manage the auto-scaling and the API systems that you're going to develop, or any way to implement, to deploy with an open source solution. You need 5 engineers, more or less, to maintain the auto-scaling systems and help develop them. Then DynamoDB, you need, this is not even cutting it short, this is cheating. 5 engineers, let's say that they deploy Cassandra and they run Cassandra at scale, or whatever sort of key value store you decide that you want to run. 5 people is a fairly small number that are developing Cassandra, and you'll realize that when something goes really bad. And so you'll have these 5 people developing on Cassandra, and then 20 people, 1 engineering manager who's probably going to sue you for overworking him. Usually the ratio is 1 every 10. So let's say you end up with 20 people. Every one of these people costs $130,000 on average. Again, the engineering manager is probably going to get out of the door as soon as he sees that number on his paycheck. So the overall is $2.6 million every year, just for these 20 people. And these 20 people are replacing functionality that you get for free within Amazon, or that Adroll gets for free within Amazon. Well, funny thing is, we spent less than that our last year on our entire EC2 costs inside the AWS cloud. It just doesn't make sense. We have a team of 35 engineers. Why would we spend 20 engineers to replicate something that is available already at a cost that is more competitive than what we can build in-house for ourselves? It's not going to be differentiating for our business. Again, we are expected to be a real-time bidding company. That's what we do. But the fact that we have that infrastructure is not differentiating. Every other company that we compete with has the same infrastructure. So it's much better to get access to something that frees our time and enables us to move very, very quickly in every direction that we need to go. And we free all of that engineering power, 20 people, so important, and they know they are so important when they come the right time of the year. And you put them to work on the actual value add that your company enables for your own customers. So why is that important to us? This is a funny graph. An investor banker, Terence Kouaji, runs this investment firm called Luma, and they developed this. It's called the Display LumaScape. Every one of the logos in this, I think there's more than 500, are advertising companies. So there is almost nobody's blue ocean here. With so many companies competing against us, it's really kind of complicated to move as quickly as you need when every one of these companies can be a threat or a partner. At some point in time, something changes. A butterfly beats his wings somewhere down South America, and somebody in ad tech decides that a new flavor of cookies came out. And so everything in your infrastructure needs to change. And the real problem in running in a system that is so dynamic, so rich of competition, and so complicated to understand and scale is that if we weren't the one using EC2, one of our competitors would. And then we'd be in trouble. If you look at, there's a lot of numbers that came out, a lot of companies have gone public lately in advertising, but also outside of advertising. If you look at, for example, Box.com, Box.net S1, that came out yesterday, I believe, they run a cost of about 21% of their revenue is their infrastructure cost. 21% is ridiculous. I said that Adro runs a $100 million run rate, and last year we spent less than $2.6 million. There is no competition in that case. If Box were our competitor, they'd have an 18% disadvantage in cost compared to us. Our product would be so much worse than theirs, and we would still win customers against them, and that would be so amazing. So the real problem is that if you're not taking advantage of the infrastructure, the costs, and the knowledge, then what's going to happen is somebody else will, and then good luck offsetting all of that. If you think you can beat, I'm sorry, I kind of don't want to say this, but if you think you can beat Amazon at infrastructure, I mean, I want to talk to you out there. I have $1 million in a bag that I can give out. All right.
Fantastic. Thank you very much. Yep. Thanks very much. Yep. Thanks, Valentino. And so this is an amazing story. And a couple of points I just want to mention as I was listening on stage. All the problems which Valentino talked about, they are not just specific to startups. They also are equally applicable to enterprises. And then things like scarce resources, your engineering talent, undifferentiated heavy lifting. Why do you have to spend resources on those things? Just focus on the business aspect of your business. And then one important thing which again customers overlook is he talked about the Box cost structure versus ad roles cost structure. If you are able to change the dynamic of that cost structure, the money you are saving, you can reinvest in your business, right? I mean, just think about that. 20% versus, let's say, like 2% or 3%, right? So you have all that money which you can reinvest in your business. That's a big thing, right? So again, just consider those aspects. It's not always cost savings, which is the most important thing. It's also the value which we are providing, and the redundant data centers and all those infrastructure. It's just an amazing story. So what I want to do next 10 minutes is go over some of the cost optimization things you can do. So you're running on AWS like they are running, right? And so you have a bill. If that bill is big, you want to reduce your spending on AWS. You want to give us less money, and that's completely okay with us. How do you really architect your application? So I call these cost-aware architectures. And so let's talk about these architectures. Just a show of hands, how many people are running on AWS right now, today? Okay, fair amount of folks. And how many people are happy with the bill they have? No one? Okay, that's a little disappointing for a TCO guy, but that's okay. So let's go over quickly over some of the things you can do to reduce your spend. So the first thing is choose the right instance types. You have 4 levers: your memory, your CPU, your disk I/O, your network I/O. So look at these 4 levers you have for each application. Look at your workload requirements. Make use of CloudWatch, which is our service which monitors your resources. Every minute you can actually get how much is free CPU, how much is free memory, how much is free hard disk. Do all that, and then once you are happy with your application performance, you can roll out to multiple AZs, and we'll look into this in a little bit more detail in just one more slide. And then make use of auto scaling. Valentino talked about the fact that when you have more requests, more demand to meet your performance, you can scale up. So add more instances. Basically, auto scaling is the service which lets you do that. You can add, scale up, add instances, and scale down your fleet of EC2 instances. So make use of something like auto scaling, and there are multiple techniques in there. You can do it through command line, you can do it through console, you can do it manually, you can do it on a schedule. So if you know your demand is going to go up, you can actually pre-program that. You can actually do based on a single metric like your CPU utilization. So again, I'll not go over all these details, but there's a service which lets you meet your performance when there is a more demand for your application or your workload. And in cases where there are demand lulls, you can reduce your cost. You can just scale down, not run those instances. Another thing which customers overlook sometimes is the granularity of your instances. So what I mean here is, look at this workload profile. So suppose your workload is something like this, right? This is how your demand looks like, or your capacity looks like over a period of time, maybe a day, maybe a month, maybe a year. So the way you can surface this, serve this application on AWS is you can have these M1 large instances. So let's say you're running these 29 M1 large instances, you're paying a particular amount, your cost is $7. Let's say this is over a day. So this is what your cost would be. But ask yourself how much is the utilization for each of these instances? Is it 50%? Is it 100%? You know, it wouldn't be 100%. Is it 10%? And if the number is a low number, let's say 10% or 20%, go to a smaller instance. You really don't have to run a large instance. So in this example, I'm running these M1 small instances. So smaller instances, in aggregate, you get the same workload done. You get the same, you know, work done. You get the same compute power. But look at the cost. It's nearly half the cost of what you have with large. And what is happening in this case, you are making these smaller instances work much harder. Their utilization is much higher. It's more than 10%. It's maybe 50%, right? So think about granularity and how you can reduce your cost while going to smaller instances. Again, something which is like a hygiene, but we see, you know, again, folks miss this point. When you're not using instances, just switch them off. You're not using a machine, your laptop, you just put that to sleep. Do the same thing with your AWS instances. So you can, again, there are multiple ways to do that. Programmatically, you can do through the console, EC2 console. You can set up these CloudWatch matrix alarms. It will send you an email and it will switch off a machine. It can terminate a machine also if you're not using those machines. Use reserved instances. Again, show of hand, how many folks are using reserved instances today? Okay, fair amount of folks, but use reserved instances. And again, as I talked about, you pay upfront some money to Amazon, and Amazon will give you more discount. You pay a little bit more, Amazon will give you more discount. So this is like buying points on your mortgage. If you're not leveraging it, you know, again, think about using reserved instances. And we have this fantastic case study with Pinterest, again, running at a huge scale. Some of the numbers you can just read there. They surface their steady state demand using reserved instances, and their, you know, their variable demand using spot and on demand. And just look at the numbers. They go from anywhere from $54 to $20 while switching from on demand to reserved instances. And the greatest thing is there is no engineering work required here. So look at the quote which is there. It's only 2 weeks of work they did to get that cost saving. So why not leverage it, right? Just go back and look at your architecture and see if you can use reserved instances. And again, there's a lot of stuff on reserved instances which is a complete session by itself. Spot instances. So this idea we borrowed from the financial markets. Anytime we take the excess capacity, put that in a spot market, it drives up our utilization and it gives you a lower cost. Look at the cost, up to 90% discount you can get if you run spot instances. The only caveat is when you're running on spot, your instances can get terminated because you bid for the instances and there's a spot price, which is the market clearing price. If the market clearing price becomes higher than your bid price, your instances get stopped. So the real question you should always ask is, what is my tolerance? If my instance gets stopped, what can I do about that? And so you should bid based on that. And again, there are a lot of details. I just want to bring up this case study. So Cycle Computing, a partner of ours, ran this last year, last November, November, December. They ran you know, a cluster of 17,000 instances, 156,000 cores. And if you look at the computing capacity, it's, you know, it's 264 years of compute capacity they ran in less than 18 hours using Spot. And they did some back of envelope math, and they said that if you are going to run this on-prem, the cost would be somewhere like $68 million. Running on Spot, only $33,000. So not every application is made for Spot, but take a look at Spot. Maybe you can start experimenting there. You can start using it for certain workloads and see if it can give you really, really huge cost savings. Storage classes, Valentino touched on this a little bit. S3 standard has 11.9 of durability. If you don't want that, so what happens in S3 standard is we make multiple copies. We make copies in the same AZs, we make in multiple AZs within the region. If you don't want to go with that, you don't need concurrent, S3 standard is designed to sustain concurrent loss of data in 2 facilities. If you don't want that, you want a lower durability, go with something like reduced redundancy, RRS. In that case, you get 4 nines of durability and your savings is up to 20%. If you don't even want that, you want long-term archival. So write once, read never sort of data, archival data. Put that in Glacier. It's 1 cent a gigabyte, and it's really cost effective, and you can put, you know, your storage, your data there. So you might ask, you know, when do I use what? So let's say you have a movie you are producing. The master copy you should always keep in S3 standard because that's the copy you don't want to lose. But if you want to encode it in different formats, you can keep that encoding in RRS. And if you have old copies, old clips, you can put them in Glacier because you're never going to use those old clips. So that's how you should think about it. Don't put everything in S3, even though now S3 prices are starting at the 3 cents and then going down from there. So it's really really a fantastic story there. But again, think about your storage classes, how S3 handles data. Offload your architecture. So make use of CDNs, content delivery networks, not just for static content, but also for dynamic content. Make use of caching. So we have multiple ways to cache. You have elastic cache, we have read replicas. Again, I'll not spend a lot of time here, but the smaller footprint you have, the less money you have to give to Amazon for running those instances. So again, think about offloading your architecture. Use application services, managed services, so relational databases, queuing, notifications, Hadoop jobs, load balancing. I'll just give you one example. If you're running a load balancer, let's say you're running a ELB, which is a managed software-based load balancer on AWS versus running it on EC2, your own software, any vendor you're out there you're using. Let's just look at the numbers there. If you're using ELB, I just picked a common scenario, your cost is $18. If you're running your own EC2 instance, just the EC2 instance cost is more than $40. So again, think about the trade-offs, and with managed services, you get availability, you get scalability, you don't have the single point of failure, you have higher reliability. So again, make use of these application services. Use consolidated billing if you're not using it today. So you link your accounts, and there is only one pair account. You have things like governance, who is spending what money. NASA JPL actually did a session at last year reInvent, and they talked about this, how people were using accounts, AWS accounts, and they consolidated all these accounts so they could track their cost. And more than that, you can also do things like share your RI discounts. So if you have storage, you have bandwidth, you have tiers, you can consolidate all that in a consolidated billing, and you get advantages. You can pool all those resources. And finally, make use of things like Trusted Advisor, which is sort of a cloud expert. It looks at your resources and it gives you a recommendation on cost optimization, on performance, on failure, on fault tolerance, on security. So things like it will tell you which ELB is not being used, EBS volumes are not being used. Your utilization is low, so you should switch to a lower instance type. So again, customers who have business support or enterprise support, AWS support, they get Trusted Advisor with no additional cost. So just a checklist. I wouldn't go through, go over each of these items here, but just a quick mental model. Like you can just go over some of these and say, okay, am I doing this? And this is not the complete exhaustive list. There are some other things which are not there on the list, but these are some of the major ones. You should always look at something like this and say whether I'm leveraging all the right best practices on AWS or not. So just to recap the session, when you are doing TCO, you are comparing on-prem. Just make use of the industry benchmarks, make use of industry averages, and always look for hidden cost. The stuff Valentino talked about, the software cost, the people cost, the cost of redundancy, cost of having multiple data centers. And when you are doing cost optimization, just make sure your architecture is cost aware and you are revisiting your architecture all the time. It's not just do it once and just leave it. So thank you with that. Thank you so much. I know this is the last session. I'm standing between you and the drinks. So I will be available here. If you have any questions, we'll be more than happy to answer those. Thank you so much. Thanks for coming.